Welcome to Lesson 2 of the Survey of Mathematics. I'm Jeremy Pletcher. Today we're going to be looking at integers. Now yesterday, or in the last lesson, we learned about natural numbers. Natural numbers are the counting numbers, things like 1, 2, 3, 4, and so on. Today we're going to add several more terms to our learning. The next term that we need to learn is the whole numbers, which is abbreviated with a W. The whole numbers are all the natural numbers, 1, 2, 3, 4, with the addition of one more number, that being the number of 0. If we add the negative values of our natural numbers, such as -3, -1, -8, those are what we call integers. In today's lesson, we're going to be dealing a lot with integers. Integers are often known by their additive inverse. So for instance, -3 is the additive inverse of 3. If we were to add those two numbers together, we would get a value of 0. That's why they're called additive inverses. Absolute value is also going to be crucial for this lesson. Absolute value is simply the distance a number is from 0 on a number line. So if I have the number 3, it is 3 units away from 0, so the absolute value of 3 is 3. If I have the absolute value of -4, well, it is 4 units from 0, therefore its absolute value is simply 4. Most students find it easier just to drop the sign no matter what it is. So there are no negative absolute numbers. It's simply the distance to 0 on a number line. So the number line can be used to compare a lot of different values. So if I were to compare two values, let's say A and B, A might be greater than B. If it's greater than B, then if I were to write those numbers on a number line, A would be to the right of B. On a number line, we may have a value of 0 here. This side on my number line would be the negative values. Let's just say a -3. On this side of 0 would be my positive values, such as the number 4. So 4 is greater than -3, so A is greater than B. This sign is the greater than sign. And for many people, it's easier for them to remember that there's an alligator, and the alligator always opens its mouth toward the largest value. He wants as much as he can get in his mouth. And so A is greater than B, and the alligator's mouth is open toward A. Now, we could have one value being less than another. In this particular case, B is less than A, if we go the other way around. However, we normally write it in a different form. Here I have A is less than B. B is the greater value. The alligator's wanting to eat B, not A. So in this scenario, since A is less than B, that means A is located to the left of B on the number line. Now they could both be positive values. For instance, 0 may be over here, A may be at 2, and B may be at 18. B is greater than A in this scenario. This is a very simple concept, but where most students have problems is when we have two negative numbers that they're trying to compare. In many cases, they think, well, wait, 10 is greater than 7, therefore -10 has to be greater than -7. It might be beneficial to either draw a number line or to think about an analogy. I often use money. You have two individuals. One individual owes somebody $7. The other individual owes them $10. So who really has more money? Well, since this first individual only owes $7, in comparison to the person that owes $10, he really has more money. If he gets paid $10 an hour, he can work for 1 hour, pay off his debt, and have money left over. Whereas this individual, also getting paid $10 an hour, if he works an hour, he's dead broke, he's at 0. So negative 7 is greater than negative 10. So let's try a couple of examples. Which sign should I use? 16 and 22. Well, which is the larger number? That one's fairly easy. 22 is the larger number, therefore my alligator needs to open up toward the 22. So I'm going to use the less than sign right there because 16 is less than 22. If I compare 8 and 14, well, 8 and 14, again, a fairly easy problem. They're both positives. 14 is more than 8, so once again I'm going to use the less than because 8 is less than 14. As my third example, now I've got two negative values, negative 5 and negative 10. So when you see those negatives, just slow yourself down a little bit and think about it. All right, we have two negative numbers. Well, this number of 5, negative 5, is less negative than this negative 10. This person only owes $5, this person owes 10. So who has more money? Well, the person that only owes $5 would have more money, so to speak. So negative 5 is greater than negative 10. If we go with negative 6 and negative 22, again, two negative numbers, so we need to slow down and think. On a number line, which one is going to be further to the right? Negative 6 is closer to 0, negative 22 is way down there, and therefore negative 6 is the greater value. So negative 6 is greater than negative 22. Now that brings us to adding and subtracting integers. For most people, it is very, very easy when they're dealing with two positive numbers that they're just adding together. But what about negative numbers? What about using the number line? The number line can be used to add or subtract integers. For many, it is a visual representation of what's going on and they understand it better. If you need to, draw number lines when you're doing this. We would typically start at 0 if we're using a number line, and then all the positive values that I'm adding together, I would move that many units to the right. So if I'm adding 5 and 8, I would start at 0, I'd move to the right 5, I'd move to the right another 8, putting me at 13, and my answer would be 13. We're going to move any of the negative values to the left. So if I'm at 13 right now, and then I see that I'm adding a negative 4, well, I'm going to need to move to the left 4 units because it's a negative number. So that would put me down to 9 as my final answer. So if they're positive and you're adding them, you move them to the right. If they're negative numbers that you're adding, you're moving to the left toward the negative end of the number line. To add integers without a number line, there are two basic rules that I encourage people to follow. The first rule is if that both numbers have the same sign, you're going to find the sum. The sum is the answer to an addition problem. So if they have the same sign, find the sum. Find the sum of their absolute values and then place whatever sign they have in front. So if I'm adding 5 and 8, they both have positive values. 5 plus 8 is 13. My final answer is a positive 13. If I'm adding a negative 3 and a negative 7, well, they both have negative signs, so I add their absolute values together. 3 plus 7 gives me 10, and then I'm going to put a negative in front of it because both numbers were negative. So that's going to give me an answer of negative 10. Now, what happens if they have different signs? Well, if they have the same sign, you find the sum. Different signs, you find the difference of their absolute values. So if I'm finding the difference between 8 and 5, so I have 8 and I'm adding a negative 5, I'm going to find the difference in their absolute values. The absolute value of 8 is 8. The absolute value of negative 5 is 5. So I find the difference of those two numbers, which gives me 3. Now, which one had the greater value? Well, 8 was positive, 5 was the negative. 8's a bigger number than 5 is, therefore I'm going to use the sign that was in front of 8. The sign in front of 8 was a positive, so it would be a positive 3. we'll work out some examples here to give you an idea. So let's try this one. I have a negative 6 plus 5. Now many people can do this without using these rules because they're very used to it. And if that works for you, you go right ahead. But I'm going to go ahead and use the rules. I'm adding two numbers that have different signs. So I need to find the difference of their absolute value. The absolute value of negative 6 is 6. The absolute value of 5 is 5. I'm finding the difference. So I'm going to find the subtraction of those two, which would give me 1. Now the question then becomes, is it a positive 1 or is it a negative 1? Well, if you recall, out of the 6 and the 5, the 6 has the greater absolute value. So I need to look at the sign that's in front of the 6. The sign that's in front of the 6 is a negative. So I need to put a negative in front of my final answer. Give me an answer of negative 1. Let's try another one. We have negative 8 and a positive 4. The absolute value of, or negative 8 is 8. The absolute value of 4 is 4. I'm going to find the difference between those two, and the difference there is 4. What sign do I need? Well, which one has the greater absolute value? The 8 has the greater absolute value, so I look in front of the 8, and lo and behold, I have a negative sign in front of the 8. Therefore, my final answer becomes a negative 4. 16 plus a negative 7. Many people just think of this as 16 minus 7, and that's fine, you'll get the same answer. However, it can be tricky, so I'm going to go ahead and go through the rules once again. So we have 16 and negative 7. The absolute value of 16 is 16. The absolute value of negative 7 is 7. I'm going to find the difference of those two numbers, which is 9. Now I need to look at my signs. Which one had the greater absolute value? 16 is greater than 7, so I'm going to look at the sign in front of the 16. The sign in front of the 16 is an understood positive, so my final answer is going to be a positive 9. Negative 5 and a negative 7. Now I'm adding two numbers with the same sign. So what do? Same sign, find the sum. The sum of my absolute values. I have a 5 and I have a 7. That gives me a total of 12. Since they are the same sign, I use whatever sign is in front of my original numbers. In this particular case, both my original numbers had a negative value in front of it. Therefore, it is a negative 12, not a positive 12. Negative 8 and a negative 3. Same sign, I need to find the sum. So one of my numbers is an 8, the other number is a 3 when I use the absolute values. I add those together, I get 11. Since both of them were negative, my final answer is negative 11. So what about subtracting integers? This is a little bit more of a challenge I've noticed throughout the years for many students. To subtract integers without a number line, we are going to change the subtraction into addition. To do this, we're going to change the second integer, the one that we are subtracting, to its opposite and then add. And I'll show you an example of what I mean. Once we have this done, we can use our addition rules. So that allows us not to memorize a bunch of more rules in order to get it. So let's say this is our example, 6 minus 8. Many people can do that in their head, but when they cross over that 0 mark, they get confused. And so what I'm going to do is I'm going to change this to an addition problem instead of a subtraction problem. So rather than subtracting 8, instead I'm going to change it to the addition of negative 8, which is the same thing. But now that it's an addition problem, I can use my addition rules. Now, how do I change it to an addition problem? Basically, what I'm going to do is if I rewrite this original problem as 6 minus a positive 8, you might be able to see it a little bit more clearly. What we're going to do is we're going to change whatever we're subtracting. I'm going to change that sign to a positive and this sign to a negative. And then I can use my addition rules. So I'm adding two numbers that have different signs, so I find the difference in their absolute values. The absolute value of 6 is 6. The absolute value of negative 8 is 8. The difference between 6 and 8 on a number line is 2. The 8 is larger absolute value than the 6 is. The 8 has a negative in front of it. Therefore, my final answer is a negative 2. So let's try performing subtraction on these problems. If I have a negative 3 minus a negative 6, my first step is to change my subtraction problem into an addition problem. So if I change this subtraction into addition, I need to change the sign of the number after it as well. So that makes this a positive 6. So now what I have is two numbers with opposite signs, different signs, therefore I find the difference in their absolute values. Absolute value of negative 3 is 3. The absolute value of 6 is 6. The difference between 3 and 6 is 3. And what value is greater, 3 or 6? 6 is a greater value, so I use the sign in front of it, which is now a positive sign. So my final answer is going to be a positive 3. 18 minus a negative 3. Same type of scenario. I'm going to change this to an addition problem by changing the subtraction sign to addition, but when I'm doing so, I also have to change the sign of my next term. So now I have 18 plus a positive 3. Most people don't need to follow the rules for that. 18 plus 3 is 21, but you are adding two numbers with the same sign, so you find the sum and then put the sign that it has in front of it. Since they're both positive, my final answer is also positive. If I go with negative 20 minus 50, I can rewrite this as an addition problem. In doing so, I have my negative 20, but instead of subtracting 50, I'm going to add the opposite of 50, which is negative 50. Now I'm adding two numbers with the same sign, so I find the sum of their absolute values. 20 plus 50 is 70, and then I use the sign of whatever was in front of my numbers. In this case, they were both negatives, so it would be a negative 70 as my answer. Negative 14 minus 29. Changing it to an addition problem, I have negative 14 plus the opposite of 29, which is negative 29. Once again, I'm adding two numbers with the same sign, so I find the sum. That gives me 43. Both of them are negative, so it's a negative 43 as my answer. So what about multiplication? Multiplication is simply a way of very quickly doing addition of the same number multiple times. So if I have something like 6 times 8, that would be the same as saying I have 6 plus 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 6, 8 different times. Well, that's a lot of work adding all those numbers up. So what we have done is we have created multiplication as a fast way of doing addition. 6 times 8, of course, is 48. I could also take 8 as my factor and add it 6 different times, and I'll still come up with my answer of 48. We could also do this on a number line, but that is not very efficient at all. The product of two numbers, however, can be a little bit confusing when you're multiplying negative numbers. So there are two basic rules for this. First of all, if the two numbers are both negative when you're multiplying, your product, which is the answer to a multiplication problem, your product is going to be positive in value. You can think of it as the two negatives canceling each other out. If your two numbers are different signs, so you have one that is positive and one that is negative, then your final answer is going to be a negative number. So multiplying two numbers together that have the same sign gives you a positive value. Multiplying two numbers with different signs gives you a negative value. Now, when this is really useful is when we have a string of numbers that we are multiplying together. As an example, let's just say I take negative 8 and I'm multiplying by a positive 5, and I'm multiplying by negative 2, and then a negative 1, and then a 2, and then a negative 3. Well, I could say I'm going to multiply these two numbers together. Negative 8 times 5, that gives me negative 40. And then I'm going to multiply by a negative 2. Well, negative 40 times negative 2 is a positive 80. Then I'm going to multiply by a negative 1. That would give me a negative 80. And then I'm going to multiply by 2. That gives me negative 160. And then I'm going to multiply by a negative 3. That gives me a positive 480. Your signs can really get confusing. So instead, what you can do is say I've got 1, 2, 3, 4 negative signs. 4 is an even number. I have an even number of negatives. Therefore, I know my answer is going to be positive. If I have an odd number of negatives that I'm multiplying together, my answer is going to be negative. And then I can just deal with the numbers. 8 times 5 is 40, times 2 is 80, times 1 is 80, times 2 is 160, times 3 is 480. I get the same answer, and it seems a lot less confusing doing it that way. But it all has to be multiplication. So having said all that, let's do some practice problems. Let's say we are multiplying 5 and 9. Most people don't need to think about this. They're both positive. 5 times 9 is 45, and we'll move on. But what about this one? 6 times 7. Again, they're both positive values. We know 6 times 7 is 42, and so we can write down our answer and move on. But what about negative 3 and 8? I have one negative and one positive. So since I have different signs and I'm multiplying, my answer is going to be negative. And then 3 times 8 is 24. So my final answer is negative 24. If I take negative 12 and 6, once again I have two numbers that have opposite signs. So the product is going to be negative, and 12 times 6 gives me 72. So I have an answer of negative 72. If I take 4 times negative 9, this time it is the second factor that is the negative, but we work it out the same way. I have two numbers that I'm multiplying together that have different signs. Therefore, my answer is going to be negative. 4 times 9 is 36. So my final answer is a negative 36. If I do 6 times negative 14, different signs, multiplying them together, I get a negative value. 6 times 14 gives me 84. So I have a negative 84 there. Division runs the same way. Division is merely the opposite function of multiplication. And so we determine whether the answer is going to be positive or negative using the same rules that we did with multiplication. If the two signs are the same, my answer is going to be positive. If the two signs are different, my answer is going to be negative. The answer to a division problem is called the quotient. So here, if I take 48 divided by 8, I get 6 because 6 goes into 48 8 different times. The quotient, or the answer, once again, to a division problem, of two numbers with the same sign is going to be positive. Two numbers with different signs is going to be a negative value. So let's try some. Let's say I have negative 56 divided by 4. So I have a negative divided by a positive. Since one of my numbers is negative and the other one is positive, my final answer is going to be negative. 56 divided by 4 gives me an answer of 14, so my final answer is negative 14. If I take 0 and divide by 16, well, 0 is not positive, is not negative, but I work it out the same way. 0 divided by 16 is 0. There are no signs on a 0 value, so I can just write down 0. Same thing if I take 0 divided by a negative number. 0 divided by negative 10 doesn't make it negative 0. It's simply 0 because 0 doesn't have a sign. Negative 28 divided by a negative 7. Now I have two numbers that are both the same sign. Therefore, they're going to be positive in my final answer. 28 divided by 7 is 4. So my final answer is simply 4. I hope this was helpful for you, and I look forward to our next lesson.